Hello friends, welcome to our official YouTube channel. Today we will study the concept of computer graphic, that is 2D transformation. First, what are the objective of our video is, first we will study what is 2D transformation, then why transformation is needed, then various techniques of transformation, then after that we will do some problem based on our 2D transformation. First we will study what is 2D transformation. A transformation is a process of modifying, repositioning the existing graphics, or we can say that any object that can be modified, change its values or coordinate, or reposition its coordinate. That means that the object is transformed. In this 2D transformation, the transformation is done on the two-dimensional plane, that is x and y. In 2D transformations, we will change the object with the help of its position. In computer graphics language, changing the position, it's known as translation. Then resize the object. In graphic we will know with the concept of cycle. Then orientation is known as rotation, and change the shape of an object is known as shading of the object. That is, these are the techniques that we use in our 2D transformation that we will study next. Why transformation is needed? Transformation is needed to manipulate the initial created object and to display the modified object without having to redraw it. Like in this example, this is your initial object that is drawn, and we will perform a transformation, that is 2D transformation. We can change this object with the help of translation. If we do translation technique, it will reposition the object. You can see that this object is on any xy plane, and its object get removed to another position, means it get repositioning from this position to this position. This can be done with the help of translation or translate. Then we can rotate that object with any angle theta without redrawing. Then we resize that object to a small size or a large size with the help of scaling. And we can change the position or shape of your object by adding some coordinates. This can be done with the help of sharing. This all techniques we will do further. uh, then we will study various techniques of transformation. In computer graphics there are various 2D transformation. That is, first one is translation, second is rotation, then third is scaling. After that there is a reflection and sharing. First we will study what is 2D translation. 2D translation is a process of moving an object from one position to another in 2D plane. It means we will move the object from our initial position to new position. That can be done with the help of your translation. In this 2D translation, we add a new shift vector or translation vector to our initial coordinates, that are x old, y old. Every point or any object can have its initial coordinates. Like in this example we will study, we have an initial coordinate of object O, that is x old or y old. Then we will add a new translation vector or shift vector, that is tx and ty. These vectors, translation vector, will be added to these initial coordinates, that is x old plus txy. Then y old plus ty will perform a new translation vector, that is x new and y new, that we will see in next slide. Here is an example with the diagram, that we have an initial object, that is O, with the coordinate x old and y old. Uh, we can move or reposition this object to another position, that is O dash. We can can do this concept with the help of adding an translation vector or a shift vector. Tx will be added with the x old, we will get a new x new, and here x old will be added with the new translation vector, that is ty. We will get y new coordinates, and then we reposition our object to new position, that is O dash, with the new coordinate, that is x new and y new. Here is an example. There is an x new, that is you will find a new coordinates with the help of your old initial coordinate of x and add your tx. Tx is your translation vector or a shift vector. This is according to your x-axis, means this one. You can see that you have x old coordinates, and you can add a translation vector. This values are will be given to you, and you after that you will find y new values with the help of y old coordinates, these coordinates, and add translation vector, that is ty, this translation vector. You will get a new y coordinate value. After that, we will study the matrix form of your translation equation, that will be represented as you have a x old value, y old value. You can add your tx, ty. You will be get a new x new with the help of these coordinate, that is x old plus tx, and you will get y new is equal to y old plus ty. This is your matrix representation of your translation vector. Then we will study the concept of homogeneous coordinate representation of your translation. This homogeneous coordinate I have taught in my previous video. You can watch that video if you want help about your homogeneous coordinate system and your Cartesian coordinate system. In this homogeneous coordinate system, we will add a new coordinate or a new parameter, that is w, or it can be represented with the 1, because w is a homogeneous parameter. It cannot be a non-zero value. That is why a new homogeneous parameter will be added, that is 1. We can perform a 2D transformation into an homogeneous coordinate. We can take a third parameter, that is 1 or a w. For this matrix representation, for with the help of homogeneous, we can do according to this 3 by 3 matrix, that is 3 row into 3 column. These are the rows and these 3 are the column. Horizontally, if we talk, this is your row, row 1, row 2, row 3, and vertically if we taught, this is your column, first column, second column, and third column. And after your expression, this whole expression, you will get a result into a 3 into 3 matrix. Here x new will be get if you multiply this matrix with this matrix. Here 1 multiply by x old, then plus 0 multiply by y old, then plus tx multiply by 1. You will be get x old, then plus 0, then plus txy. It will represent same as in previous slide, that is x old plus tx. Then you in this row you will multiply with this column. First 0 multiplied by x old is 0, plus 1 multiplied by y old is y old, then ty multiplied by 1 is ty. Here you will get y old plus ty, and after that in third row 0 multiplied by x old is 0, 0 multiplied by y old is 0, then 1 multiplied by 1 is your 1. This will give you another homogeneous coordinate matrix values that will also be same as that you have solved in previous slide, that is x old plus ty and y old plus ty. You will get a new x1 and y1. Then there is some numerical problem that will be solved with easy method. First, you will given a circle C with radius 10 and center coordinate is 1 4, means x is your 1 and y is your 4. Then apply the translation with distance 5 toward x-axis and 1 toward y-axis. Obtain the new coordinate of C without changing its radius. Mean we have an x old, this is your x old, this is your y old, and this is your tx, and this is your ty. uh, we will solve this example. X old is your 1, y old is your 4, then translation vector tx is your 5, distance that is 5 toward x-axis, tx is your 5, then ty is your 1, and you have to find a new coordinate that is x new and y new. You can solve with the simple method, that is x new is equal to x old plus tx. X old is your 1 from this value, then tx is your 5, you will get a new x value is 6, and y new is your 4 plus ty is 1, that is 5. New coordinate that you will get is 6 comma 5. Now you can place this on your graph. First you have a 1 and 4, that means you have object C with the coordinate 1 4, 1 for x and 4 for y. After translation with new coordinate, that is 6 for x and 5 for y, you will place that coordinate on your 2D plane. You will get this object reposition from this position to this position, or you can say that from this position to this with your translation vectors values. You will get a new values, that is 6, that is x new, then the y new will be 5. You will reposition initial object to a new position, that is C dash. Next we will study 2D rotation. This is another technique in 2D transformation. In 2D rotation, process of rotating an object with respect to an angle in 2D plane. In this 2D rotation, we will rotate a point to a new point, new location with the help of an angle theta. Let we study with an example. We have an initial object O with our x coordinate and y coordinate. These are our old coordinates that are given to us. Then we will given an angle, a rotation angle, that is theta. We will perform an trigonometry expression on that, and we will get a new coordinate, that is x new and y new. We will study with an example. Here there is a formula to solve this equation. We can find a new x that is equal to x old multiplied by cos theta minus y old multiplied by sin theta, and you get y new values from x old multiplied by sin theta plus y old multiplied by sin theta. Theta value will be given to you, and there is a formula derivation for your these cos theta and sin theta, from where these values are come. Let we study. For this you have to know some basic formula of your trigonometry, that is sine value should be your perpendicular over hypotenuse, and cos value that will be get is based upon hypotenuse. This is a simple formula, that is Pandit Badri Prasad har har bole sona chandi tole. This is a simple trick to learn these values. In this diagram we will given initial values x coordinate and y coordinate. If we plot these x and y, we will get a simple line, or these line at some angle with an x-axis and y-axis. This is your phi angle. If we have to find an x y dash and y dash, and where it is placed with the help of your new angle, that is theta, we can solve with the help of an trigonometric equation. Here P represent your perpendicular. B means base and HRP means hypotenuse. If we will solve this line, initially we have point xy, then we will get new points, that is x dash and y dash. What will be the new points? With the help of this angle theta, we can solve this expression. This is your cos phi plus theta. You have to find this whole angle, because this is your new point that you will get, and for that you have to take this whole angle. Then you will take a cos phi plus theta is equal to base upon hypotenuse. From this, cos is equal to base upon hypotenuse. Here base is your this horizontal line, this one, this x dash. uh, Here I represent that x dash. Base upon hypotenuse. Hypotenuse is your angle line that is opposite you to your 90-degree angle, this one. Base is your x bar, that is x dash, or we can represent with the x nu, and hypotenuse is your r, this radius r. And after solving this expression, we will get we cross multiply this r to this side, r cos phi plus cos theta, after opening this bracket, minus r sin phi sin theta is equal to x bar. This is your equation 1. Then for another, you will get a sin phi plus theta, that is with from this formula, sine is equal to perpendicular upon hypotenuse. Here the perpendicular is your this line, this one dotted line. This is your y dash, and hypotenuse is your r, this one opposite to 90-degree, this one r. And after solving this equation, you will get r sin phi sin theta plus r sin phi cos theta is equal to y dash. uh, Put these values, that is x for this triangle, this one, this x is same. With the help of this expression, you will get x is equal to r cos phi, comma y will be this value, this dotted line, this y. You will get y is equal to r sin theta. You can place this x and y values in equation 1 and 2. You will get a simple equation, that is x bar is equal to x cos phi minus y sin theta. Y bar is equal to x sin theta plus y cos theta. Here x bar is your x new, y bar is your y new, and x is simple, x is your x old, and y is equal to y old. This is your x new, that is x bar, x old, your simple x multiply by cos theta, then minus y old simple y multiply by sin theta. Here is that equation after derivation, this one. Then we will do a matrix form rotation equation, that is representation of your rotation with the help of matrix form. Here is your x new, y new. You will have to find the new coordinates. Then you have two matrix, that is cos theta minus sin theta cos theta multiply by your x old and y old. You will get values for x new and y new. Here you will solve this equation. These rows multiply with this column. First you cos theta multiply by x old minus sin theta multiply by y old. Then this for next row, sin theta multiply by x old plus cos theta multiply by y old. You will get new values for your new coordinate, that is x new and y new, or you can say that x bar or y bar. This can also be done with the help of your homogeneous coordinate. You can add additional new parameter, that is 1 or w, and this will also get the same value that you will get in a 2D transformation or your Cartesian coordinate system. Then there is an numerical based on your 2D rotation. You will given a line segment with the starting point 0 0 and ending point 4 4, and apply a 30-degree angle. Theta is also given, and line points are also given, that is from 0 0. A line will be made from 0 0, first coordinate, and the ending point is here 4 4, and you have to apply a 30-degree rotation anti-clockwise direction, and you will get new coordinates after solving it. Here is your x old and y old. X old and y old is here 4 4, this from this 0 0 to this 4 4, x4 y4, and you have to apply a angle theta, that is 30-degree anti-clockwise, and that after that, after solving this equation, you will get x new and y new. Here is a solution to find x new. X old multiplied by cos theta minus y old multiplied by sin theta. After solving this, you will have a theta angle. Cos 30 is equal to under root 3 by 2, and sin theta is equal to 1 by 2. You know the values of these cos theta and sin theta from your trigonometry table. After solving this, you will get a new value, that is 1.46. X new is 1.46 and y new is 5.46, and you after plotting these values, you will see an object on x is 1.46 and new object, and y is 5.46, and you will see a new rotation of your object, initial object to a final object, this position. And this is a metric representation of your 2D rotation. uh, X new will be found with the help of cos theta minus sin theta, and multiply by these values, you will get a new values, and this will also result same, that is x new is equal to 1.46 and y new is 5.46, and after that you will get a new object with the help of an 2D rotation on 2D planes. Thank you. Please like, subscribe, and press the bell icon for new updates on new videos on these topics. Thank you.